as we have discussed that the Rutherford model failed due to certain limitations which he could explain. So the next attempt was made by Bohr model, and you will be surprised to know that Bohr was actually able to explain many facts about the atom, because the main limitation which the Rutherford was not able to explain was the electron distribution exactly. So he was able to explain many facts about the electron distribution, electron movements, electron jumping states, more like that. So we will look forward to it. See, so what he said, according to him, atom is somehow spherical. Atom is somehow spherical, right? And the atom is made up of subatomic particles called as electron, proton and neutron. So now we will look for the charges. See, electron is negatively charged, proton is positively charged, neutron contribute in mass, but actually it is neutral, it has no charge. Okay, then he said that, I'll repeat again, atom is somehow spherical in shape, formed of subatomic particles. The main three subatomic fundamental particles, electron, proton, neutron, negatively charged, positively charged and no charge. And then he said that in the center of atom there is a small dense mass that is called as nucleus. It was actually proved before only by Rutherford. So he is just clubbing those things and make you more easy, because any scientist when represent his model, he has to take all the facts which are proved. So even this was discovered before, so he actually clubbed all those things and also resolved the issue related to the electron distribution, and that is why his model was successful. So we are just doing it step by step, that how he discovered, and actually he gave the detailed information in order wise, so that it should be clear in your mind that what actually the atom is and what is the structure in the atom and how these subatomic particles are present. So repeating again, it is spherical, formed of subatomic particles, you know the charges also now, and in center there is a nucleus. Now where are these particles present? So proton and neutron are present in the nucleus. We know proton is positively charged and neutron has no charge. So that means nucleus contain only positively charged particle and neutral particles. So that means the charge on nucleus is also positive, right? Then he explained that outside nucleus there are shells present. Outside nucleus there are shells present. Shells can be as many as we can make. We name them as, the first shell which is closer to the nucleus is written as 1, that means n. N corresponds to the number of shell. 1, the second is 2, third is 3, and even we can use the alphabets for that. But we can't use the alphabets starting with the A, because it is being given by Bohr. There is no hard and fast rule for it, but for the sake that it was given by Bohr, so Bohr gave the first shell as K, the name as K, L, M, so on. So either you can use the term 1, 2, 3, or you can use the term for the shell K, L, M, and so on, right? So he said outside nucleus shells are present. So these are shells. We can also call the shells as energy levels or orbits. Shells are called as orbits because they are spherical. And why they are called as energy levels? Why Bohr gave this term energy level? The reason behind it, that he said that these orbits have fixed energy. These orbits have fixed energy, right? So that is why the name given to these shells can be used as energy levels as also. And then he said that in shells electrons are present. In shells electrons are present, and one important thing, he said that electrons are not stationary. Electrons are not stationary, they are moving in a circle in their specific orbits with certain speed. So they are not stationary. And he also explained that actually the major drawback of the Rutherford was that when any charged particle revolve in a circular path, it emit energy, shorten its path, spiral down into the nucleus. This was the main drawback. Now how he resolved that limitation? Look, he said that each orbit corresponds to the fixed energy. That means as long as electron will revolve in the same shell, it will neither lose energy nor it will gain, right? Whenever electron will remain in the specific shell, it will neither lose energy nor it will gain energy. See, so by this postulate, he resolved the limitation of the Rutherford model. And coming to the next point, it must be striking in our mind that how many electrons we can put in K shell, how many electrons can be there in L shell, why can't we put all the electrons in the single shell, what is the need of so many shells? So, how Bohr resolved it? He said that the electrons are present in the orbit, it's right, but the electrons, these orbits are filled in, the electrons are filled in the orbit by following the Bohr-Bury rule. What was that? It was 2n square, right? What is n? As I told you, n corresponds to the number of shell. So he said when n is equal to 1 means the first shell, that is K shell, then the maximum electrons it can accommodate is given by this formula 2n square. I have put n as 1 because n is the first shell we are looking for. So maximum electron it can accommodate is 2, right? So similarly we can calculate for the second shell. So second shell, that means L, putting it 2 into 2, I have put again n as 2 because we are looking for the electron in the second shell. So it comes out to be 8. Similarly for third shell, I am putting 2 into 3 square. So it comes out to be 18. So these are the maximum electrons that a shell can accommodate. So this is how you can calculate the maximum number of electrons for the different shells, K, L, M and so on. And by writing this, we can actually arrange the electrons following the Bohr-Bury rule.